Okay, this is a recording of AP Calculus Chapter 1, Section 1 is on lines. Everything we're going to do in calculus is really going to stem from the beginning of this first section. In reality, in calculus, first semester focuses on what's called a derivative. And a derivative is essentially the same thing as slope. It's the instantaneous slope of a curve at any point. So it's all going to start with this slope formula. So keep in mind from your Algebra 1 class, most of you probably had this in 8th grade, that the slope is the rise over the run, or the change in y over the change in x. Remember, subtract the y's over subtract the x's. Okay, you got to rise out of bed before you can run in the morning. So this is big. And if you can highlight things like this, great. Another definition is this equation given here. Y minus y sub 1 equals m times x minus x sub 1 is called the point slope equation line that passes through this point. Okay? So this y sub 1 is just the y coordinate of the point that you're going to use. This x sub 1 is the x coordinate of the point that you're going to use. And if you just go y minus the y coordinate of that point equals the slope times x minus the x coordinate of that point, many times on the AP test, we can just leave the equation of a line written in this form. As a matter of fact, on the free response, we're going to write it in a very similar form. The only difference is the y sub 1 is going to be on this side. So I actually prefer this. Y equals y sub 1 plus m times x minus x sub 1. So whenever I ask for point slope form, I'll put linearization next to it because it's called the linearization form. Okay? And I would rather have it written this way than this way because we isolate the y by adding the y sub 1 to the other side. Okay? The equation given here, y equals mx plus b, is the slope-intercept equation of the line with the slope m and a y-intercept b. The slope of the line given here that passes through these 2 points, okay, where x sub 1 cannot equal x sub 2, because if that happens, you would have a vertical line, and a vertical line has no slope. We can always find the slope, like we stated up here at the top, by doing rise over run. Delta y over delta x, subtract the y coordinates over subtract the x coordinates. Remember, vertical lines have no slope. This is critical that we remember this. Vertical lines have no slope, where horizontal lines have a slope of 0. Remember, vertical lines are up and down, horizontal are left and right. Okay? For lines that are neither horizontal nor vertical, it is handier to remember a few other items. Number 1, that parallel lines. We have parallel lines, and this means if and only if the slopes are equal. M sub 2 equals M sub 1. Okay? Lines are perpendicular if and only if the product of the slopes of the 2 lines equals -1. In other words, the slopes are negative reciprocals. Okay? And I tell you right here, in case you forget, that this symbol means if and only if. All right? Keep that in mind. For your notes, I just summarized it all right here. Vertical line through a point, we have to remember, is x equals the x coordinate. It's on the first test. Because it's very critical that we know the difference between a vertical line and a horizontal line. Horizontal lines through a point is y equals the y coordinate. That easy. There is a typo, and there will be some typos along the way. Okay? And I would change this right here and put a subtraction sign. So make sure you put that in. Y minus y sub 1 equals the slope times x minus x sub 1 is called point slope. But remember, I'm not going to ask for point slope. I'll say point slope, but then I'll put linearization form. That just means I want the y coordinate added to the other side. That's it. Slope-intercept form, y equals mx plus b. And then they call this general form. Remember, with general form, we really don't want to have fractions on these coefficients, so we can clear out the fractions. And you always want the x term first, then the y set equal to c. Some books call this standard form, but more and more books are calling this the general linear equation. I like general form better as set equal to 0 because that's how we consider most general forms as set equal to 0. They're not going to ask for, on the AP test, rarely, if ever, ask for an equation line written in standard or general form. Really, if you just leave it in point-slope form, that's good enough. Okay? So find the slope between points A and point B, and then find the slope of the perpendicular. So here now I'm going to start writing the work. In order to find the slope, when we find the slope, we need to subtract the y-coordinates on top. It doesn't matter which one I start with, but if I'm going to start with point B, then I need to start with point B on both the top and the bottom. In other words, y minus the y-coordinate, 1 minus negative 2, over 2 minus 1. This becomes plus a positive, or 3 over 1, which is a slope of 3. Okay? That's it. That means that the slope of the perpendicular is going to be the opposite reciprocal. Don't forget to negate it as well. Negative 1/3. Example number 2. Find an equation for A, the vertical line, and B, the horizontal line through the given point. Most of the time on tests and quizzes, I'll actually just write this out for you. Horizontal line. And have a nice blank for you to plug it into. Okay? And you just have to do the answer. But we have to know that a horizontal line is y equals the y coordinate of the point, or a vertical line is x equals the x coordinate. It's on the first test. It's on the first review. I tell you it's going to be on the test. Hopefully, the class of 2021 will be the first one where everybody gets this particular problem correct on the test. It has not happened yet in the last 15 years that it's been on the test. Okay? X equals the x coordinate for vertical, y equals the y coordinate for horizontal. Write an equation line that passes through the point P and has a slope m. So to write the equation of this line, y equals the y coordinate plus the slope times x minus the x coordinate. And then that becomes plus a positive. That is good enough. If it's on the AP test free response, we would leave it. We don't want to make errors on the free response that are computational errors that we don't need to do in order to receive a particular point. And this is a perfect example. We would leave it. I like this form better than y minus the y coordinate. I just put the y coordinate here. It's a lot better, and this is how it's always going to be written on the AP test free response. Okay? Now, we are going to practice writing it in slope-intercept form because on the multiple choice they will do that. So we just distribute the slope and then add the constant terms. There it is. Hopefully you don't need to show this step on your homework. You should be able to distribute and add at the same time. Okay? Example number 4 is exactly the same as example number 3 with one little change. That little change is the simple fact that they do not give us the slope this time. We've got to find it. Otherwise, it's the same. So I'm going to say the slope is subtract the y coordinates on top. -2 minus 1 is -3. Over subtract the x coordinates on the bottom. 2 minus -2 becomes 2 plus 2 when you subtract a negative, or 4. The more computation that you can do without writing down, in some ways, can be more helpful. You won't make as many mistakes. So here's my slope. I can use that slope through either one of these points. It makes no difference. So we could have this for an answer. Now some of you are going to say want to say y minus the y coordinate because that's how you've done in all your other classes. But why not get y by itself and just put the y coordinate on this side? So I'll use this point to start. Y coordinate plus the slope, which is negative 3/4, times x minus negative 2 becomes x plus 2. There it is. Done. You can leave it like that. It's on the AP test and they ask for the equational line, which they will do frequently. We would leave it like this. However, we're going to practice converting this to slope-intercept. And again, I'd like to see you be able to do it in one step. It's negative 3/4 x. Okay? And if you have to write more down, that's okay. But look at negative 3/4 times 2, that's negative 3/2. Negative 3/2 plus 1 is going to be a negative 1/2. Okay? Fractional work, you just got to keep practicing it. That's how you get better at dealing with fractions. Let's check, though. I'll do this one in pen for you. Using this point, we should get the same answer. Y equals the y coordinate, which is negative 2, plus the slope times x minus 2. This is good enough on the free response, and I'm going to emphasize that over and over because we're not going to do extra work that we don't have to do if it's free response question. When we distribute, this time we get negative 3/4 x, and again, I'm going to say negative times negative is positive 3/2. 3/2, okay, positive 3/2 minus 4/2 is a negative 1/2. We get the same equation, whether we use this point or that point, because we're finding the equation going through those 2 points. Okay? 2 examples left, and that'll be it for the notes on the first section. Write an equation for the line with the given slope and a y-intercept b, and then draw a sketch of this. So on this particular problem, we're going to write it in slope-intercept form. Why not? They're telling us the slope, they're telling us the y-intercept. Y equals 1 times x is just x, plus the square root of 2. Now you will see on most of your note packages, I provide a graph for you, so that you don't have to do this. This will be one of the very few times that you're going to have to actually put a gridded graph in. I put them in there for you. Yep. And on the homework, I think that you'll see. Now occasionally I forget to put it, I may have forgotten to put it in there, so you'll have to do that. And the only reason why I did this is I want you to get used to the fact that we're going to get irrational numbers a lot in calculus. So the square root of 2 is between the square root of 1 and square root of 4. Square root of 1 is 1. Square root of 4 is 2. So it's in between 1 and 2. As a matter of fact, it's about 1.414. So we just estimate that right there. And now I can still count the slope. It's up 1 over 1. Up 1 over 1. Up 1 over 1. Down 1, back 1. Okay? And then we're going to connect those lines. If you have a straight edge, that's great. A lot of times on the notes, I will have a straight edge as well. Okay? But I want you to get used to the fact that we're going to get slopes that are going to be irrational. We're going to get y-intercepts that are irrational. Remember what irrational means. It is a non-repeating, non-ending decimal when you write it in decimal form. Common irrational numbers. Any square root that's not a perfect square is probably the most common. But remember, pi is an irrational number. 3.1415 goes on forever. E is an irrational number. Most people memorize the value of E as 2.71, but it's a non-repeating, non-ending decimal that goes on. Okay? Example number 6. Write an equation for the line through P that is parallel to L and perpendicular to L. So this is where we get the parallel perpendicular that's going to come in on some of the last few problems. So the very first thing we have to do is figure out what is the slope of this line. The best way to figure out the slope of this line is to get y by itself. Write it in slope-intercept form. So subtract the x term from both sides. If I subtract x from here, it goes away. Subtract x from here, I get a negative x plus 4. Divide both sides of the equation by 2. 4 divided by 2 is 2. We really don't care about what the y-intercept here, just as long as we don't get the same y-intercept. Then that would be a problem. Okay? And now we just want to, for part A, we want to use that same slope. So here's my slope. There's the point that it's passing through. Here's how I like to write this. Y equals the y coordinate. I'm not going to write it in point slope form at all. I'm going to use this, it's a manipulation of that point slope form called linearization form later on in our calculus book. But we're going to start by doing this right away because this is how all of the free response solutions are presented on the AP test when they ask for the equation of a line. So it's the y coordinate plus the slope times x minus the x coordinate of the point. And I'm using this point right here. Okay? That's good enough. Unless I specifically ask for slope-intercept form. Just leave it this way. You don't have to add it. It's right there. Done. Just plug it in. Now I am going to convert to slope-intercept just so that we're practicing on this fractional. Because a lot of times what really creates problems for students on some of the multiple choice questions is just the fractional issue. Just having to compute with fractions without a calculator. Distribute negative 1/2 x. Negative times negative is positive 1/2. 1/2 plus 2 is 2.5. But typically we're going to write it as an improper fraction, which is 5/2. Okay, that's part A. That's parallel. Here's part B. On this one, we just have to remember when I'm finding slope, and this is the symbol for perpendicular, an upside down capital T, I'm doing two things. I'm flipping. That's my sound for flip. And I have to change the sign. It's still going through the same point. I don't change the point at all, so I'll write that right here. So y equals, instead of saying y minus the y coordinate, I'm just have the y coordinate right here. Y equals the y coordinate plus the slope times x minus the x coordinate of the point. That's it. Boom. Done. It's a lot easier. You don't have to worry about getting y by itself. It's right here. Okay? It actually saves you a step of having to add the 2 to the other side if we write it this way right away. Why say y minus 2 over here when I go to slope-intercept? I'm going to want to put the 2 on the other side anyways. 2x minus 2 plus 2 is just y equals 2x. So this is actually called linearization form. It's a manipulation of point slope. This is called slope-intercept form. Okay? All right, at the bottom of each one of these, you will have a book, and it will be typed up. But I also have every one of these problems that have been converted to a worksheet so that you can work right on the worksheet. I provide, in most of those problems, I'm going to provide a graph for you. You'll see it as the year progresses. Okay? That's it for the very first lesson. And now you're going to want to work on the worksheet that you have provided.